It's my great pleasure to introduce Barbara Laine. Barbara is a fellow at Arup. She comes from Dublin, as you will hear, and she did a bachelor's in civil engineering in Dublin and did a PhD in fire engineering at Edinburgh. She's a fellow of the Royal Academy of Engineering. She's won a Royal Academy of Engineering's silver medal, so great honours both. And she was also a member of an expert witness for the Grenfell inquiry. So she's exceptionally well qualified to talk about fire. So Barbara, we look forward to hearing your talk.
Thank you. Okay, well, thanks to everybody for taking the time to come here for my presentation and for Imperial's very kind invitation. My name is Barbara, and I'm what's called a chartered fire safety engineer, and I work at Arup. I've worked on fire safety problems and solutions in all different forms in buildings, in concept stage, design, construction, and building in new stages for projects all around the world. And more recently, I've been acting as an expert witness on various disputes regarding construction quality, and I'm currently spending all my full-time project time in Arup as a fire safety expert witness to the Grenfell Tower inquiry. Now, I know Imperial were very keen that I'd speak a lot about Grenfell, but it's not very appropriate actually at the moment. But I am going to just talk about it briefly here. Throughout my career, but particularly since I attended the scene of the fire, and most particularly after what I saw and smelt the Friday morning after the fire, I've been analysing and worrying and questioning and pondering the issue of how one creates a fire-safe world. There are no words possible to describe the carnage that morning, and it was a carnage that was witnessed by a very small group of people, expert in disaster recovery, with a few people like me present with no prior experience or understanding of what utter carnage truly entails. It was and remains so, nothing compared to the carnage experienced by the residents of the tower, their family and friends during the fire. These are cold, hard facts, and they are not some to be disparaged emotions. And this was central London in 2017. So it's really not possible, in my opinion, to agree that a simple return to the so-called business as usual model is acceptable after such an event. Okay, so I'm clear that to create a fire-safe world is an exceptionally complex problem, hence my use of the word conundrum. But I'm equally clear it requires a solution. Despite all my own experiences and the experience and skill of all of those people around me, we've not been able to easily reach for some swift resolution for the state of safety in our built environment as we find it today. I'm also clear, and I don't believe I'm alone in this, that it is time for some positive, proactive, honest and collaborative behaviour and action to enable a transformation out of unclear and uncertain complexity and into a more systemic, resilient and effective means of creating a safe built environment. The fire safety conundrum, I've come to believe, isn't even simply a fire safety science and engineering problem. And I want to try and explain what I mean by this today. Fire has been a source of light, comfort and heat to humankind throughout the ages. It's a familiar process, and for the arsonist in all of us, it can even form a pleasurable part of our leisure time. It can also be powerful, uncontrollable, and dramatic in effect and consequences. This is a movie of a fire in an Arup building. The force and scale is breathtaking. And of course, the sounds of ever-familiar measures to protect us are always in the background of day-to-day life. The impact of fire is part of our shared history, part of folklore, part of society. How people and property are protected from the complex phenomenon of fire has a long history. Here in the UK, our regulations stem from the consequences of the Great Fire of London in 1666. This was a time when this city was built with timber, which burnt unnecessarily, disproportionately, with apparently very low loss of life, but significant consequences for the city itself. When this fire happened, there was no fire brigade, nor any rules for building safely. After this fire, change was slow, but then insurance companies provided firefighting. The city was divided into areas, each with a fire watch in place. New rules were created for constructing buildings and streets. Since that event, and almost consistently until recent times, a cornerstone of building fire safety was to rely on non-combustible materials. This is very useful historical context now. But that was then, and this is now. There are conflicting demands of the built environment in these times. In the last 25 years, cities have grown larger and more quickly than ever before. Fishing villages have become megacities. Deserts have become urban playgrounds. By the middle of this century, 75% of the world's population will live in cities. Cities occupy less than 1% of global land, but generate over 2/3 of the world's economic output. Modern methods of construction are rapidly evolving in response to this increasing urbanization. The rate of urbanization is huge. 2.5 billion more people will be living in cities by 2050. But signs of looming problems have been emerging. The Lacrosse building, situated in Melbourne, is a 23-storey mixed-use building and had a fire on the morning of the 25th of November 2014. In the words of the municipal building surveyor, he said, "The fire at the Lacrosse building is a first in Melbourne in that it directly affected approximately 450 to 500 people who required immediate evacuation and accommodation." He added, "The fire spread vertically and was not contained in the room or area of fire origin. Fortunately, in this instance, there were no fatalities or serious injuries." Then another notable fire at the Address Downtown Hotel near the centre of Dubai, New Year's Eve 2015. This time the fire started on a 20th floor terrace of a 63-storey hotel. About 1/4 of the facade was consumed by the fire. The fire spread in all directions, and this was ACP cladding. Modern methods of building construction relying on combustible materials were now under scrutiny and of rising concern. It was acknowledged in some quarters at that time that there were hundreds of buildings in the UAE and hundreds of buildings in Australia, respectively, cladded with similar materials. So on the basis of hundreds of buildings having been constructed in this way, I will speak about the scale of the problem in the UK later, we were and are now dealing with a fire safety problem not from an individual building perspective, but at an entirely different scale. I use the phrase city scale. By this I mean large portfolios of existing buildings that require attention now, coupled with an increasing demand for new buildings and associated new critical infrastructure. But urbanization is also changing cities in another way too. There is 1 billion people who live in informal settlements around the globe. 33% of city dwellers live in slums. Fire is one of the primary threats in these informal settlements too, as kerosene lamps typically act as a source of heat and light. This image shows here what happens 1 hour after a lamp has fallen over. Fire in an informal settlement can affect thousands of people, as well as loss of life. The consequences of fire include serious injury, destruction of homes and property, and short and long-term impact on livelihood. Therefore, recovery from fire is a long and difficult process. This is particularly exacerbated in informal settlements, where a lack of insurance, financial instability, and insecure tenure are common. One must also consider the approximately 25 million people living in refugee camps, another consequence of the shifting world. These people also live without adequate fire protection. The scale of these fires is caused by non-existent access routes, scarce water provision, the materials used to construct the shelters. These are matters of city-scale planning and consequential effects. It requires expertise from disciplines of so many forms to tackle the multifaceted problem created by the scale of issues facing cities. These are issues substantially remote from the typical perception of what a fire safety scientist or engineer does, and also remote from the scale of problem the fire safety profession is typically associated with solving. A final contributing factor to increasing urbanization is to do with migration, with 258 million international migrants recorded at the end of 2017. But there's another factor impacting the built environment, and this is climate change. This too is also becoming relevant to fire safety in the built environment due to the increase in the number of fires in the wildland-urban interface. The wildland-urban interface includes locations where urbanization meets the natural environment and where communities build homes in areas of forest, for example. The recorded evidence shows the increasing area of wildland fires year on year. This includes this country. Climate change is creating the conditions for wildland fires. The risk of human-caused ignition is increased in wildland-urban interfaces and therefore increasing the frequency of unintended fires. The consequences of fire at this interface includes impact on life, livelihoods, environment, and agriculture. But ultimately, what all of this means is that fire causes 130,000 deaths annually. Fire-related burns cause 5% of all injury-related deaths globally. In comparison, war accounts for 2%. In 2016, approximately 1/5 of the world's population from low to middle socio-demographic index countries, but half of the world's deaths due to fire occurred in those countries. The impact of regulation to improve the energy performance of buildings has also driven the rise of modern methods of construction, particularly those with highly insulating polymeric insulation foam, and further mass timber elements are increasing in popularity substantially. There is pressure on the construction industry and the stakeholders in the wider built environment to stay on that journey of limiting our impact on the built environment, and a strong drive to achieve sustainable development. This is development that meets the needs of the current generation without compromising the needs of future generations. What all of this creates is something very far away from a single building and its fire safety solution. Instead, we have transitioned into a complex system containing multiple buildings with fire safety problems, a strong demand for ever-increasing numbers of new buildings, interfacing with infrastructure, interfacing with wildland, and for some places, the presence of informal settlements. But I have one final reflection on this complex system. The very purpose of buildings are changing. There is an increasingly flexible definition of workspace, of living space. The recent Ocado fire in Hampshire adds an interesting dimension, and I don't have any special insider knowledge here, just to be clear. This is a large factory space devoid of human occupation, occupied instead by robots, apparently fully fire protected. But once the fire started, human intervention was required, interfacing robotic operations and human firefighting. The Ocado share company price dropped. They had invested in this operational process and technology and were apparently selling it to others. What does it mean for that technology, that operational approach, when it interfaces with a fire? If it is true, and I've no factual evidence yet, that the fire started in the robot, now we have an absolutely fascinating fire scenario and resulting building condition, and resulting operational failure and resulting property loss. What a complex problem to try and unravel. There's only going to be more building types like this, not less, as the digital transformation of the built environment continues. What this all shows is the side effects of rapid urbanization and rapid advances in new technology are piercing through the built environment and making some spectacular demands of those who create it. I don't know about all of you, but I find these very profound matters, and they feel very far away from ad hoc fire safety research or a register of chartered fire safety engineers or a knee-jerk regulation change after one disaster or another. We need something far more substantial, such as a common definition of objectives to help us all achieve clearly defined safety goals. I've set out some of my suggestions here. Complex systems thinking is therefore required to understand the direct and indirect consequences of fire in order to prioritize investment in fire risk reduction. Closer to home, let us now ask ourselves if our current safety system is working. The answer is a very large and loud no from me. The government have confirmed a total of 474 buildings in England clad in unsafe materials. The most recent public statistics show 72% of public buildings with unsafe cladding are undergoing some form of remedial work. But this figure drops to 8% for private buildings. The current statistics mean 26,500 homes in England are currently clad with similar cladding material to Grenfell. This means 20 months after the start of the building safety programme, more than half of the total number of identified buildings have had no remedial works done on site at all. What we need is a building safety programme for these properties in England where the works are prioritised as a function of risk to life. What we also need is a high-performing system that can produce safe places to live and work and which protect our infrastructure and our communities. So now I want to turn to some potential solutions or methods to achieve solutions. This is a work in progress, but I hope the themes I present today might provoke some discussion and consideration and become cornerstones of a wider concerted plan for change. Producing a safer world is clearly a multifaceted problem. What are the cornerstones in this multifaceted system that can create or cause or contribute to a system which will produce effective, resilient, fire-safe spaces? Today, I just want to try and focus on three, which I've classified as scale, fair and honourable dealings, and digital transformation. So first to scale. There is a substantial need for an increased understanding of the number of stakeholders and technical disciplines needed when creating something in the built environment. There is a scale of integration across the technical disciplines and stakeholders needed in terms of a common understanding and commitment to solving the fire safety problem. There is a substantial scaling up needed of skill. Fire safety knowledge cannot carry on being a niche discipline area. There is a substantial scaling up of a core group of experts, yes, but also a substantial scaling up of education across the wider disciplines involved in the built environment. Everyone from the architect, the mechanical engineer, the contractor, the firefighter, statutory authorities, product manufacturers and suppliers, the government itself, regulatory bodies, there's such a long list. There is also a substantial change needed in the wider context understanding of either expert fire safety scientists and engineers, as well as from all the other disciplines and parties involved. We cannot carry on producing graduates or apprentices who think about fire in such a narrow niche way, or not even as relevant to them at all. Truly interdisciplinary thinking and considering fire safety at the scale it is impacting our cities and the built environment is key. This requires commitment to an education system at the scale needed. along with wider strategic thinking and understanding, coupled with a more extensive expert capacity. There is a need for a totally different scale of investment in research. This needs to be at a scale that brings fire safety science out of its niche domain. It needs to be at mainstream scale. We also need a shift in emphasis from pet projects or ad hoc projects at universities or other institutions towards an effective and organized applied research plan. We in industry have some serious problems, and we need rapid assistance to solve some very practical and immediate problems. We need interdisciplinary effort. The next cornerstone, I'm assigning the title Fair and Honourable Dealings. This is the complex part of the change needed, in my opinion. This revolves around behaviour, agreeing levels of acceptable risk in our communities, and actually valuing safety, being prepared to pay for safety measures, but coupled with being honest about what are relevant safety measures. I'm not a fan of change for change's sake if it doesn't in reality actually improve safety standards for the community. So some suggestions. We need a common definition of acceptable risk in order to understand and plan for the consequences. As a profession and as a society, we are not agreed on acceptable risk, and there has been a trend, therefore, not to plan for related consequences. We need transparency regarding performance requirements and acceptable solutions from our regulations, from our statutory guidance, from the materials and products relied upon to create safe buildings and spaces. We need honesty about grey areas and proactive engagement to resolve them, and accepting this is a dynamic situation that requires regular review. This requires government, industry, and academia commitment. It means considering the impact of our thinking and decision-making on the community rather than on the bottom line. There is a stark need for more robust construction materials and construction systems to create our safer built environment. Determining the fire performance of products and systems, the detailing needed to ensure a resilient response in real fires is also complex. There is a lot of scientific effort needed to urgently assist industry in this. There is an acknowledgement now of an industry-wide problem here, as communicated in the Hackett Review and the publicised data from the Grenfell inquiry. We need also an inclusive environment regarding fire safety expertise. This is a hugely political arena and not appropriate for me to go into detail here. But from my current perspective as a designer, there are issues around the need for the fair compensation of technical services, incorporating firefighting requirements more robustly into design and construction standards, the provision of equipment and education suited to operating in the modern built environment, being an industry that proactively deals with those needs through design and construction processes, industry demanding rigorous enforcement of standards, and industry placing safety at the heart of the works they are providing for the community. And finally, valuing safety. Being an industry and a government, aided by academia, by the way, in being prepared to invest in robust and appropriate safety measures. Who is going to lead this change agenda? The last proposed cornerstone for today is to do with investing in the benefits of digital transformation to help us create a safer world for our communities. The more I understand the power of digital buildings and digital technologies, I see opportunities for being able to gather and analyse data at scale, relying on techniques such as what is termed user experience to create a different calibre of smart building for communities and for firefighters, being able to rely on sensors in buildings to drastically improve maintenance regimes of fire safety systems, or to provide real-time data for emergency preparations and live emergency decision-making. Finally, having a common source of information about a building for long-term quality assurance, maintenance, and understanding. Digital transformation and its role in improving the built environment is such an exciting subject in itself, even if it means learning about cockroaches, I learned today. There are plenty more cornerstones to define and decipher yet. For this world-class university, there is a huge role for you in shaping and leading the transformation of the built environment. I am inspired now, all the time, by the young people entering our technical disciplines because of their refreshing commitment to change and their high demand for honesty and fairness. This particular little problem is down to you to sort out. Thank you very much.
Thank you, Barbara. We've got plenty of time for questions. Can I ask you to identify yourself if you have a question, please? Yeah.
Just goes to Imperial College.
Hi.
Thank you, Barbara. Really interesting talk. I had a question. Since it's such a multidisciplinary field, how do we move fire safety science out of the niche that it's currently in?
Well, I think I was trying to hint at a little bit more organisation. So I think the first step is accepting that fire safety isn't something kind of either too familiar to think about or so expert that you can't get involved. So I'm trying to make it something that it feels very relevant to everyone. And so it becomes part of the education of, far more disciplines, say, than the so-called classic fire safety engineer. And then as well as education, research and other things, and that investment in those subjects is at a more orchestrated and organised level and at the scale we need. Because we've just been just a certain size for such a long time, and that's clearly not having the impact that we require in our communities. There are some people who can make decisions to make that different, in my opinion.
Other questions? Yeah.
Hello, Matthew Bonner from Imperial College. That was a great talk, thank you very much. I was curious about, again, also talking about unifying these fire safety problems with the larger community. I was wondering, what do you think are the largest barriers in the way of doing that right now? Like, what is stopping people doing it already? Why haven't people done it?
I think as a profession, so say both in industry and academia, I think we're quite protective of what we are individually doing. And I think there's just a new level of openness needed to help us start to try and look out and see who else we should be working with. Because if you take smart buildings, we actually need so many people who can do that weird cockroach stuff that I can't even describe. But I know that that technology and that skill and that numerical ability is the kind of thing I need to be working with from now on. If I'm going to do something totally different in a building, it can be applied into, say, the construction industry. So there just seems to be a mind shift needed in who we should be working with, and then who else is relevant to safety.
I've always had the feeling that the construction industry lags behind other industries in terms of adoption of innovative solutions, innovative technology. You talk there about the use of smart buildings and advanced technologies, if you compare it to the technology industry, but even oil, chemical. What's going on there, do you think? Is it because the consequences are perceptibly less, or is there something intrinsic to the built environment?
I can say a few things there. I have not been able to answer that question, and I've genuinely been thinking about it, because even in Arup now, when we bring in new technology people, just the way they behave and what they expect, they have this thing about failing fast. So you try out something, you fail, if it doesn't work, you fail fast, you try something new, okay? It's this attitude where you're very open about what's working, what's not working. just even having that kind of attitude in the construction industry. Can you imagine that, even on the most simple things? And I think we seem to have become the most old-fashioned grouping. I don't know, I was trying to touch on fair reward for technical services as well. I just don't know if there's something about it's not valued, if it isn't understood. It seems to be a curious mixture of the two. But we are way behind where we could be if we chose to make that decision to place safety and other things at the heart of what we're actually doing when we carry out a construction project. Because we are all in construction in the end. And I think that's another little problem that we might have, that some of us don't understand that everything has to get built one day, and understanding how that is done properly must happen much earlier in the process too. So I haven't cracked that one, but it kind of can't carry on anymore. That's what I'm clear on.
Thank you very much for your talk. I have a question. So we can see that nowadays more and more fire safety regulations are applied for new buildings. But are there any approaches for old buildings that were built in, for example, as Grenfell in the 80s or even earlier? Are there any measures to prevent the fire spread in old buildings?
Did you say there's more and more fire safety regulations?
They are more and more applicable for new buildings. Yeah. So when the building is constructed, it's already applied there, but it was not like this decades ago.
I don't agree that there's more and more fire safety regulations for new buildings, but I'm just being a bit pedantic. I understand your point. The issue of how existing buildings are dealt with, let's say, by law and regulation in this country, I can't tell you what I think, because I'm in the middle of doing that for the Grenfell inquiry at the moment. But there is something about having a very large existing building stock and understanding its intrinsic level of safety at this time and making a decision, yes, about what we're going to do about that. You can read my 1,000 pages on the material alteration clause in the building regs another time. Yeah.
You introduced Fire Tucker from Tata Steel.
Hello.
Hi. You introduced this as a global problem. I can understand it's a global problem, but can you see any world best practice that we should be adopting?
Yeah, I was trying to say it was to try and think beyond. I think in fire engineering we think about the building we're working on. I'm trying to get people to think a little bit more big picture. I think there are some other countries, yes, that have different rules about how certain materials are used, yes. And I know that from some of the countries I've worked in. So for example, how some of the codes in the States consider fire resistance or what should be in an external envelope are somewhat different to what we may have thought was acceptable here. So there is different standards and there are samples of best practice in other places. We'd have to pick a specific subject. I can't think of one country that's substantially better at everything we need at the moment. Is that okay? I think there's pieces from all different places. And some countries are slightly ahead of us because of their own problems as well, as you know, in Australia and other places. Is that okay? Yeah.
There was a fire not far away from here at the Mandarin Hotel up in Knightsbridge. It was a recent renovation. It's a first-class operator. It's the Mandarin Hotels. It's a prime owner. And the hotel had to shut down, but it was right after the renovation phase. How would you explain that an incident of this level can happen, given that they already have the permits and everything else, given that you're closer to the subject?
Yeah, but I don't know what was happening in that hotel with respect to its maintenance regime and its fire prevention regime. So, I mean, I would just be entirely speculating if I was to say something. I try not to do that. So there will be something about what caused the fire there and how it spread. I don't have any information at all.
standing on the shoulders of Arup, I'm paraphrasing him, if quantity surveyors got interested in aesthetics and architects got interested in cranes, we'd be getting somewhere.
Yeah.
So you're kind of saying if fire engineers get interested in construction and architects get interested in fire, we're getting somewhere.
Yeah.
But the poster out there, in Guillermo's poster, basically says...
What's on the poster? Yeah. Guillermo, what's on the poster?
Oh, the posters. Oh, sorry, I totally misunderstood.
Yeah. Oh, you mean technical work being presented across the hall? Yeah.
It basically says that architects don't know how to build fire safety.
Who wrote that down? Which hold up your hand and answer Ian's question, because I'm not. Yeah. Is that written on a poster in the room across the hall? That architects don't know what they're doing? Yeah, I don't agree that architects don't know what they're doing. I think that's a very rude thing to say. And I don't like when they say fire safety engineers don't know what they're doing. I think it would be much better if we had a much more respectful understanding of what we all need to do to a very minute level of detail, actually, to create a safe building.
It's kind of strange, really.
Well, I'll go rush over and read who wrote the sentence and suitably admonish them later. But I'm sure they were trying to be helpful and apply for more research funding for their work. Yeah.
It's a game of windows, isn't it?
What's a game of windows?
It's got to be a game of fenestration, as it used to be in the fire grading reports after the Second World War.
Other questions?
Laine from Imperial College. Thank you, Barbara, for such an amazing talk. I was curious about, you talk about forest fires and informal settlements. How does Arup approach the fire safety engineering of these problems?
Okay. Well, we are very clear that we don't know enough at all about forest fires or wildland fires, so we're trying to get some skill and expertise there, so we don't do that at the moment. And then for informal settlements, I think you know, well, Danielle is here actually, she and others in Arup have been working very hard with all different types of communities and stakeholders in that area to try and help them understand some fire safety goals and objectives. So Arup and Danielle, who's here, are trying to enter into that area and work out what kind of practical things that we can do. But that's a new thing as well. Yeah. Hello, cockroach person. Yeah.
Hi.
We need to have a chance, by the way. Yeah.
I'm Robbie Vaganathan from Imperial College. Actually, it was just a bit of a follow-up on the question that was just asked. When you said we don't know very much about forest wildfires, is it even possible to characterize what we don't know? What are maybe the major issues that we need more information on?
Do you want me to do that? So I'm not an expert in wildland fires, and I never will be because I'm too obsessed with buildings. But there are bodies of research work, and some of them work with you, bodies of people who are getting into the parameters and lists of problems that need to be solved. I don't like to kind of make up answers when I'm not an expert in an area, so I can't be more specific. But Guillermo there, do you see him? He works with you. He knows all about it.
You seem to be saying that there's a conflict between the desire for better insulation in order to help combat climate change and a tendency there, particularly retrofitting, and then a tendency to reduce fire safety.
Yeah.
Is there a way around this one?
Yeah, so I think maybe there might have been a bit of a rush to satisfy one driver without carefully thinking about consequences, so in this case for fire safety. And it can't be that we just give up on energy performance of buildings and rush off to think about a single driving parameter now, which is fire safety. It's about the careful consideration of both. And there is a way of using polymeric insulation safely. It just has to be thought about properly and detailed up and installed properly in a building. So it's about the careful consideration of, of conflicting risks, if you will, or conflicting drivers.
You earlier said that the construction industry should drive to be like more flexible or take on more new technologies faster, and that they mainly don't do it because they're afraid of failing quickly. Do you think there's enough, in some sense, enough economic incentive for the construction industry to fail because we can build buildings already, so they do their purpose often? And also, can we afford to fail in the construction industry? Because failing in, for example, in technology, and for a mobile phone, for a laptop, or other things, is relative. They're not really big consequences, but failing is more similar to what would happen in the aviation industry.
Well, I was imagining failing in a theoretical sense. So if you're doing fire testing or trialing or something numerical or having some kind of innovative thing you're trying to work through, that's the type of it that I was talking about, how new technology companies are interested in being honest about failing fast. One might say that we actually are failing in the construction industry at the moment, because we do seem to have a rather long list of problems that now need to be resolved in our existing buildings. And so we need to work out how to solve them and work out how not to create another generation of buildings with some, intrinsically unsafe construction methods.
Better labelling of materials, because for a personal story, my daughter was buying a flat in Greenwich, Enderby Wharf, and
what wharf?
Enderby Wharf, the Barrett's development along the Greenwich Peninsula.
Is that one of the buildings with the unsafe cladding on it?
She did it. But I asked the Barrett's people, I said, how do I know that's safe or not safe? And they said, we've used all the current regulations, we've built according to the rules, it's safe. But I said, how by looking at it can I tell it's safe? And it's not, you can't. So is there more scope for some sort of better labelling of materials on the outside of the building?
Exactly. With these new technologies, having some kind of common platform, like a digital platform, where you can literally check the materials, what are they called, what do they do, in some kind of digital replication. We've been talking about it for such a long time. It's still not really happening. There must be someone very clever who can do that very quickly, and then you'll actually know. I would ask, though, how do they know they complied with all the regulations when they built their building? But we'll leave that one there. Yeah, I'd love to hear about that. Yeah, no, but it'd be nice if they answered it properly, wouldn't it? And they gave you some competent evidence other than a single sentence. That's what they should have done for you.
You seem to say, how much of you think of a perfect solution is, how much policy change is required compared to engineering knowledge change? Because I think you seem to say, it seems to me that we know a lot about how to build safely, but it's not necessarily being implemented. And the implementation is down to regulations or things not being followed or other things. And there seems to be a need to change the policies of how people behave to do this. And how much do you think is it engineering not being applied or things not being available compared to we need to change the way how we do things?
So I won't assign any percentage responsibilities at the moment, okay? But I hope I made it clear that I think it's a two-way thing. So we need educated government, educated regulators. When I say educated, I'm talking about fire safety, not in a kind of a disparaging way. They understand fire safety, okay? The government, the regulators, the policy makers have to understand better the consequences of decisions made, don't they? So if they change rules for energy, we have a duty to understand other consequences. And then that equally applies to the parties who are trying to comply with those rules and the decisions they make. So I'm not prepared to say, you know, if there's some kind of horrible out of balance. At the moment, I'm prepared to say there's an equal level of change required very, very quickly, not in 1 or 2 generations.
You said at one point, I think, that we need to agree on what's an acceptable level of risk. Yeah. And I just wondered if we could unpick that a little bit. Because it seems to me that that's actually a very difficult thing to achieve. Yeah. As individuals, we each have different ideas of what's an acceptable level of risk, and also we're entirely inconsistent about the levels of risk that we will accept in different circumstances. So how can we define an acceptable level of risk, and therefore how can we determine what's the correct level of resource to allocate to fire safety vis-a-vis anything else?
Yeah. So I agree with all the points you've made. I would like to understand, say, if one took the current regulations, or let's say the decision by government to allow people to carry on living in the buildings with the unsafe cladding, how it's been quantified, what the risk to life is. There are techniques for doing that, well-trodden techniques, and what the consequences are as a result of that risk. And I think there are very formal, well-evidenced methods to do that. And I would like to start introducing that much more explicitly into our designs. I have control over design, and ideally into guidance or regulation coming out towards designers. There are technical ways of doing that.
Of course, but
yeah.
For instance, I mean, if you take something like a Hatfield rail crash, for example, what was done after that was to place speed restrictions all the way across the network until they had replaced all the rails which were susceptible to gauge corner cracking. Now, one can almost certainly do a calculation which says these are the number of people who were killed in car accidents as a result of the increased car traffic, as a result of those restrictions on the network. So it wasn't, as it were, a logical calculation based on that kind of risk analysis. It could have been, but it would have been unacceptable to the press. And it would have been unacceptable, the politicians wouldn't have allowed that risk to be carried, because if there'd been another train accident, their heads would have been on the
But I think you kind of answered your own question, thankfully, so I don't need to... No, I'm very relieved, because don't we have the same problem, okay, now? Because I would like to know who's done a risk and consequence assessment of even, say, the public building stock, or not. I would like to know.
Is there more room for a stronger regulation of the building sector, like the FAA?
Yeah.
Someone that could really step in.
I'm a fan of that, but I think I'm in the opposite kind of political, I think that's very political now, isn't it? Personally, I would like clearer, goals and objectives, so then you can do more explicit or complex or clearer solutions to well-defined goals, but I'm not in charge.
Time for one more question?
Yay. Okay, thank you.
Yeah.
John Sargent, I used to work for Castrol.
You used to work for
Castrol.
Oh, yeah.
Great move for Katie.
Yeah.
I just wondered whether you think there would be any impacts on fire safety depending on the outcome of the current discussions in Parliament on Brexit.
I mean, it's like my dad came, so it gave me the opportunity to say I'm an Irish European passport holder. about to be deported from this country. So what do you think I think about fire safety and Brexit? I'm not answering that question. Yeah. Yeah. But I have started speaking in Irish more recently. I will say that. Yeah. Okay. Thanks very much.